Okay, welcome back. New lesson here. This is a gas law. We are learning about gas, and we are dealing with gas. There are three variables: temperature, pressure, and volume. Okay. Today we are learning about this law called Boyle's law. You don't have to remember the name, but you have to remember the relationship. This law involves pressure and volume. Pressure versus volume. Temperature is constant. Temperature is constant. Keep that in mind. Constant means it does not change. So it cancels out. So all you have is this equation. P1 times V1. First pressure. Initial pressure. So initial pressure. Initial volume multiplied together equals final pressure times final volume. Okay. Initial is the 1. Final is the 2. So when you read this, you have to understand the context so you know which one is which. So there are four variables. Remember, we have pressure and volume. So pressure, we recognize pressure by some units such as millimeter of Hg, ATM, atmosphere, torr, kPa, kilopascal, or psi if they give us psi. But I gave you some equivalents here. Okay. Another one, standard condition here. Remember, standard temperature. If you see STP, standard temperature and pressure. Standard temperature is 273 Kelvin, but we don't have temperature here on this worksheet because this does not involve temperature. Standard pressure is 1 ATM. All right. So every formula, this is the formula you use. Here's a sample question. Make sure that the two pressure units are the same. If they are not the same, you have to convert them so that they're the same. So it doesn't matter which pressure unit you use, as long as they are the same, you can use this equation. The volume units are the same as well. Remember, volume is going to be milliliter or liters. All right, I see milliliters and liters here, perfectly fine. So for Boyle's law, you see temperature, and it says they give you temperature. It's constant. It cancels out, so it's irrelevant. All right. So number one here, a gas occupies 12.3 liters. That is a volume. At a pressure, that is a pressure. So list out your V1, P1. V1 is 12.3 liters. P1 is 40 millimeter of Hg. V2 and P2. What is the volume when the pressure is increased to? So this goes to that, so that you know that is your P2, 60 millimeter of Hg. And we are looking for V2. This is our X. Okay. So to solve for that X, you plug it into the equation. Now check. Do we have the same pressure units for pressure? We do, so we can use that equation now. Always check. So V1, P1. Remember, V1, P1 equals V2, P2. V1 is 12.3 times 40 equals X. I'll put 60 first. X times 60, same thing. All right. So how do I isolate the X to get it by itself? I divide each side by 60, divided by 60, and that'll cancel out this 60, and that gives my X. X is which is equal to V here. So punch that in your calculator. 12.3 times 40 divided by 60, and I get 8.2 liters. It's going to be the same unit as your V1. Okay, it'll be the same unit. Yeah, it's not difficult, guys. It's just algebra. This is just algebra. You have three variables and you have to find one. Okay. If you look at number 5 here, let's look at number 5. 500 milliliter of gas is collected at that. Okay, so you know this is your V, this is your P. What will the volume be? So what will is future, so this is the past tense, so this has already happened, V1, P1. V1 equals 500 milliliter. P1 equals, P1 over here, 745 millimeter of mercury. V2, P2. What will the volume be at standard pressure? Oh, we know P2 is standard it says standard pressure here, right? The word standard pressure is already, it's a number. It's actually a number. It's 1 atm. But do we want to use 1 atm? No way. We want to use the 760 millimeter of Hg so that it matches with our P1. Okay, so that's the confusing part. If you get stuck there, which P do we use? Look at the unit for P1. So plug in 500 V1 times P1 745 equals V2 times your P2 760. So divide by 760 on both sides, and voila, you get your V2. V2 equals, calculator time, guys. Really, it's all calculator. 500 times 745 divided by 760, and I get 490 milliliter. See, so 490 milliliter. Alright, so we've done 2 of these. Look, the volume went down. What happened to the pressure? The pressure went up. See, volume down, pressure up. Look at number 1. Volume down. What happened to pressure? Pressure went up, 40 to 60. So this relationship, ladies and gentlemen, pressure goes down, volume goes up. Pressure goes up, volume goes down. See? There's more pressure, and we did this with our lab activities, and this is what we call inverse relationship. Inverse. A lot of words here, a lot of stuff going on here, but that is there. An inverse relationship, very important word as well. Okay, so let's have a little bit of time here. So let's do one more. So you'll see that there's 7 problems, and I'm doing 3 of them with you, so it makes it pretty easy. Let's pick one. Okay, I like this last one here. Convert 338 liters. Liters is a volume, so V1 equals 338 liters. P1 equals 63 atm. V2 is what we're looking for. Oh, we keep looking for V2. And then P2 is equal to 1 atm. Standard pressure. This time I'll use the atm. 1 atm. So I haven't shown that. So here it is. Hope you've been listening. So all this is asking for the volume. What is this nonsense? Oh, there you go. Number 4 is asking for a pressure. Yeah, the only one question asking number 4 is only the question asking for pressure. So everything else is asking for volume. So yeah, it's new volume at standard pressure. Yeah. So it seems like this worksheet here is asking us to get used to standard pressure. Remember, standard pressure is 1 atm. So plug that in. 338 V1 times P1, which is 63, equals V2 times P2, which is 1. So just multiply those 2 numbers and you'll get your V2. Just multiply that, right? Because you divide by 1. So do that, and the unit would be V2, which is liters, the same unit as your V1. Because pressure already matches, volume will match it. Yeah. It's not difficult, guys. You just have to remember to identify those units. Remember pressure, atm, focus, atm, millimeter of Hg, torr, kilopascal. Okay, that's your pressure unit. Your volume unit is milliliter and liters. So if you understand that, the equation is fairly easy. P1 V1 equals P2 and V2. And as one goes up, the other goes down. This is what we call an inverse relationship. Keep that in mind. One goes up, the other goes down. Wonderful. Good luck working on the rest of this. It should be easy. Set up, again, every question just set up the same way I did. List the variables, B1, P1, B2, P2. So it's less confusing. Alright, I need to see that on all your work. Make sure that is done on every single problem. It's not a lot. 3.5 questions for you, almost 4.